lake.
Welcome everyone to the last session of the day, and I'm pleased to introduce Raj Babu from Agilisium. Raj has 20 plus years of technical implementation and domain experience in business intelligence and analytics solution. He's very passionate about applying design thinking and digital transformation principles for analytics, business intelligence and insights. Agilisium, which is formed from Agile and Elysium, is a design thinking applied big data, business intelligence and analytics services company. Its services are designed to accelerate its customers' digital transformations, data strategy in analytics, BI and insights. And Raj is the founder of the company. So please welcome Raj.
Thank you. I think you can all hear me, right? Yeah. Well, for the sake of maybe this one, I'll use it. So this presentation is more at the architectural level, not so much detail in the actual technical implementation level, because some of the sessions were at that level of detail. So we are going to see more like the industry trends and the architecture from the enterprise data strategy and stuff like that. So we're going to talk about, I think my introduction has been given. I have 20 years of experience and more so in focused in building enterprise data lake, enterprise data strategy and stuff like that. Elysium has been given. So some of the key topics that we'll be touching today, it will be design thinking, digital transformation. Many of you would have heard digital transformation, what digital transformation really means from data aspect. So that we are going to talk about. We're going to talk about data lake, the benefits of data lake, what were the shortcomings of EDW, and how the data lake is kind of filling some of those gaps. And then we are going to talk about EDWL. Basically, how the EDW and the data lake architecture combination, we're going to a little bit touch about that. And we're going to put some, go through some reference architecture that's been, on Amazon Cloud, the data lake. I like to call it lake on cloud. So we are going to a little bit go through this. So these are all the key points we'll be covering today. So how many of you are familiar with digital transformation and design thinking here? All right. So digital transformation is basically, if you see all the Gartners of the world now, the changes happening in the industry, like the IoTs of the world and all that stuff, it comes under the digital transformation. Traditionally, IT has been used for transforming the finance and the supply chain, those kind of stuff. Now what's becoming is technology as an enabler, not only in these specific traditional where where it has been very effective. Technology has gone much further in helping it at every end, in the physical supply chain, in the machines, making them smarter and all that stuff. So that broader change where technology is impacting everything, that's what is a digital transformation. And the digital transformation, if you see, it's one aspect of it is data. So it has many different aspects. One aspect of it is data, and little bit. So what is that data change of the digital transformation? That's some topic we'll be touching. And another thing is design thinking. Design thinking is something which has been there for really 20 years. And design thinking is the one which has kind of created product like Apple, iPhone, and many other products. traditionally design thinking has been applied in creation of physical products. When how a consumer would use a product, how they would interact with the product. So that is where design thinking has been traditionally used. But now I think currently the trends are they are taking the principles of these design thinking and applying to analytics. So many of the things is one simple example. I'm not going to talk too much about design thinking today, but one simple example I can give in the design thinking is when we talk about organizations about data. Usually the conversation starts. Okay, what are all the systems we got? What are all the data? Let's get the inventory of that. Let's get the inventory of all the data. And then let's try to and then let's give a priority of these systems and the data within them, and then let's try to build a BI or analytics system. Traditionally, give or take, that's what I've seen in the last 20 years. But the design thinking applies is completely in a different direction. Okay, forget all that stuff. Forget what we got. Forget what is all the system. What is the business we are in, and who are our consumers? What we are trying to understand about our consumers, how data can help us in understanding our consumer or our product consumption and all that stuff. Start from there and then come back way and then see what are all the data you got and what are all the data you don't have to answer that question. So completely a different angle of approaching the problem. The problem with the previous one is you are consumer empathy. What they are really trying to do, what is that we need to service to them, and how we can apply, what are the things how we can use the data to understand that, so it goes in a different direction. Same thing, think outside in the data. So, especially when we are doing either B2B or B2C. B2B is, even in the B2B, your end consumer, most of the times, is a C, because your customer is another B, but their end consumer is a C. So we need to see data always, we need to think outside in. The reason is the reason I was telling. We always are bound by what is the data I have got within my organization. You only see that. So let's assume you're a product shipment company, you only see, okay, how much product I've shipped, what is the POS, what is the inventory, that's all you see. But really, what is the consumer buying it for? How are they using it? Those data we don't have. But since we don't have, if you are completely going to ignore it, then you are really not trying to understand what your consumers are doing with it. So think outside. And so then think now, if we recognize that problem, okay, I don't have the data of my consumers, how they use my product, maybe at least you will take some steps to go and approach that problem. So you will try to gather some data, you will try to create some use case, whatever it is, to understand. So that's what, when you think about the data, don't think just inside what you got only, start thinking what is outside, what is all used. So that is another most important approach that we bring into the customer's thought process. Data monetization, this is another most important thing. The data monetization, traditionally most of the organizations have been using data for reporting what has happened, there is clearly a value for that. I'm not saying there is no value, but it's an operational value. It says what's happening in my business. It gives a visibility to the business, so that should I create more products? Should I order more products? Should I keep a bigger inventory, or should I keep a smaller inventory? Yes, it gives an operational value, but it doesn't really give you more than that. So data science really gives that. It really helps you to understand your consumers, how they are understanding. But in the end goal is data monetization. So how do I monetize? So for example, one example I can do is that I can say, based on the industry I've been working, is that in the music industry, I have a decent amount of experience in the media and entertainment. They see, okay, they're the artist, and the album sells, the song sells, they have been tracking, and they've been using that information, the sales information, how can we use it for promoting the album? If it's moving well in a certain segment, can we use more radio plays to influence that market and get the consumers excited and all that stuff. But there is another aspect to, so that is all they've been doing. There is another aspect to it. Another aspect to it is data monetization is, okay, see the artist, and then what is the demography of the fans of that artist? What kind of products they like? What kind of products they consume? And how can I work with those products and brands, and can I get a royalty or some kind of monetization from that products and brands? So it's looking at different aspects, looking at your data, but not just from an operational perspective, how you can, within your organization, whatever you are doing, how to exploit it, but think outside the box. How can I take this information and can I exploit that in any other way for a new revenue stream? So when any data science project is set up, they need to first start with defining what is my data monetization. Without having a data monetization plan, a data science project is just a science project. It's really not going to go anywhere. So that is another important thing, that we need to follow in these data lake and big data projects. Automation, it's just we need to build enablers. So most of these stuff, new data coming in, there are certain new data. Yes, you have to completely build a new process to process it. But if there is a small changes, can you build programs that can smartly understand those minor changes without huge intervention and programming? Can it capture the data and process it? So complete as much as possible, making smart automation in your data recognition and ingestion process. So these are some of the key aspects based on the research that we have seen and the trends in the industry we have seen, that digital transformation part of data is happening. Moving on. So one of the key reasons why the shift from the EDW to EDL, the traditional EDW approaches has always been, give me the requirements and then I'll go and build a system based on that requirement. I mean, everybody knows that doesn't work anymore because the requirements keep on changing. There is no way you can put enough number of resources, and we don't have enough time to constantly make those changes. So that's the reason the new approach with the digital transformation is that the business doesn't want the IT to be a gatekeeper. Traditionally, that's what they've been seeing, whether the IT likes it or not. The business always saw, IT wants to control the data. They want to control the ETL program, how we bring in the data. They want to control the reporting, what access we have. We don't want the IT to control the data. We want completely to have the access. So self-service is very big. And there is really the self-service, it's not so easy to provide with the process and methodology we are following in the traditional EDW process, because it's the nature of it. You have to build a ETL program, and you have to configure your enterprise reporting, whatever it is, and then only they can access the data. With the EDL, it's a completely different approach. They say, okay, we want self-service. So you get the data, it comes and lands in your data lake, and that's it. There is some governance and some process and control, so you cannot let any data come into your data lake. Very minimal, but those things can happen within a day once the data shows up. So bring in your data, and then they can do the self-service, they can do the analytics, they can do the visualization, whatever. It's not going to be snappy and very easy like pushing a button in a report and getting the data. It's a lot more than that. Everybody here knows that, but at least it's a possibility. With the EDW, that was not even an option. So that's one of the main reasons. Clearly the trend is towards EDW has clearly failed in that space, and enterprise data lake is the direction to go to kind of close those gaps. Sorry, yeah, you can. So I kind of went through these challenges, business which have been complaining. The BA is always incomplete. We don't have all the information. They use the word the architecture is too complicated because they cannot get anything inside. So these are common things we have heard from the business. That they complain about the traditional EDW systems. We can explain, we can give the reasons why it's the way it is, but they don't care. They don't care. What they want is that data to be available to them and they'll be able to access. So, these are the pain points set up with EDW. Moving on. So this is, we have implemented this cloud EDW on cloud architecture for last few years. This is particularly a reference architecture on Amazon Cloud. So this one of the clients is a media and entertainment company, major in Los Angeles. So they get many partner information, hundreds of millions of records per day on the digital transaction happening. Take it, load it into the data lake, directly goes into the data lake, and then the supply chain information from your traditional supply chain systems comes into the data lake. Everything lands into S3 data lake, and then you can take it from there. Directly you can do query. Today there were some company called Cubole here. There are many other products that you can use, Databricks or Spark, and there are a few other options within the Amazon too, where you can directly access those data. Your data scientist should be able to do that. And then use that data lake to power your BAU projects in the Redshift. And then have your reporting system configured to your MicroStrategy, business objects, Tableau, whatever is your reporting system, configured to the Redshift. Everything could be, the entire microcosm can be in your AWS cloud, and it could be running from there. Key components of that, S3 data lake, and then Redshift Spectrum. Basically Redshift, I'll come to Redshift Spectrum shortly. Athena, AWS Glue. This is not yet, AWS Glue is still not GA. It's still, I think, very soon to be. And then AWS QuickSight. So these are the product combination with which completely you can develop your both enterprise data lake and BI system on Amazon Cloud. Moving on. Sorry. So, what is the key problem data lake solves? To me, from the experience I've seen, the key problem data lake solves, data latency and the ETL challenge, the ETL bottleneck, because there is not enough. We cannot take. It's impossible to take all the inside and outside data into your enterprise reporting system. Data requirement, and it can access. It can be the central data exchange between these systems. It is a warm archive, so you don't need to completely do the cold archive anymore because it's so inexpensive, so scalable. You can always put the data in your data lake, and it's always available for access. And it is a great place for analytics, data science, data wrangling, and all that stuff. It serves all these purposes. And then it obviously with it being the ODS, it powers your data marts and whatever other applications that needs those data. All right. I've covered some of this. Some of the key benefits. No need really to do ETL everything. Ad hoc analytics. Whatever you need to do immediately, you can do on your data lake. No latency, and there's really no development. There's really, you don't need to put a lot of, get your data in a certain, the only effort you have to put is bringing in the data, bringing in making some format, basic formatting work so that it's highly performant and stuff like that. Very, very minimal. That's about it. It's extremely inexpensive. There is no compute. You are only going to pay for the compute when you are going to use it. The only thing is the low cost storage. All right. So we went through this in the previous one, the value chain. So the source system, we ingested, basic ingestion, and then the preparation is what for the data science and wrangling we do it. And then the process part is for the reporting part. So preparation and the discovery is in that within the data lake. Whatever it happens within that. So it's and then there is with your data lake. I'm not an expert in this subject, but you can run your complete security, metadata, governance on your data lake. So very much possible. It's not like your data lake is not so secure. There could be some challenges you have to figure out, but it's there are as we speak there are more products coming and they're getting more and more mature.
I have a question.
So
if you're ingesting semi-structured data, you still need to do the cleansing and have it in another copy, right? Another table, if you may. So when your BI, it will be more faster instead of reading directly from the semi-structured data.
That's true. That's true. That's why I said there is no. This never takes away the need for BI, but only what you have defined. So, like, see the previous problem with the EDW and data mart. For any business person to access the data, until it's loaded into a database, they couldn't even access it, right? Now with the data lake, there are tools available, they can access it. But that is not going to be, let's assume you get a report in your BI system in 30 seconds. It's not going to be 30 seconds there. But before it was not even a possibility. You cannot even get, doesn't matter even if it is 3 hours, you cannot even get for the user. Now, it's not going to be 30 seconds. It's probably going to be 3 minutes or maybe 5 minutes, but at least it's an option. They get it and they can see. So it's a perfect place for a laboratory. So you can put a data, you can check it out, build the whole thing, see the value of it. If it's valuable, you really build your KPIs and everything, whatever you want to build, clean it. And then if it's good, then take it and give it to your BI team and say, okay, this is the model I have built in the, on the data lake. But I want it much more faster, much more snappy. Go and load it into the BI, right? So it's a lot more efficient and a lot more faster way to get it. And until the BI develops, so let's assume in that case the BI says, oh, it's going to take 3 months for me to do it. It's going to be not so easy. It's going to be difficult, but you have an option to get this done for the duration of 3 months until it's there in BI. Before that was not even an option. So, consumers of your EDL and EDWL. I'm going to jump into what is EDWL shortly. So, anyone and everyone impatient to getting the data, which is pretty much, I'm sure every organization has some of those. They want, they didn't even get the data, but they wanted some reports out of it or some information out of it. And, two, you can, your data science team and even the organization where the cost, because everybody knows if we do our analysis, 70% of the data in any BI system, it's really not accessed. We just keep it because at some point of time, maybe somebody will ask for it. So, all those, so during that time, that 70% of the data is spinning in high expensive disk, in an expensive BI MPP system. You don't need to keep that. Now you can analyze and say, okay, you can maybe build 3 tiers. You can build, okay, here are all the expensive, highly accessed. I'll keep it in the high tier, high performance, and I'll create a tier 2. And then, something not so much accessed, I'll keep it in tier 3. It's not available. What takes here 30 seconds, 3 seconds will take, 1 minute in the tier 2. It's going to take 3 minutes in the tier 3 or, the other tier. It's as simple as that. But it's always available. Okay, so there is another part I want to touch upon. With the Redshift Spectrum, this is a new product released by Amazon. Something interesting is coming up. So I call this EDWL. The reason I call EDL, so EDW is Enterprise Data Warehouse, everybody knows here. EDL is Enterprise Data Lake. EDWL is a hybrid of both. So you get the best of both. So in the EDWL, Amazon Redshift Spectrum, the new product that has come out, it serves both. What it does is that Redshift is traditionally a MPP BI system, and then under that is you can have your S3 data lake. Now what Spectrum is doing is that so far with Redshift, without the Spectrum, just the Redshift, it can you can load the data from the S3 into the Redshift, and then you can run your BI or whatever from the Redshift. Everybody can see that. But the Redshift user can never see the data in the S3 directly. They cannot. You don't have the visibility to that. With Redshift Spectrum, now they are creating a capability where, let's assume you have like 2 years of data, 2017 and 2016 data in your Redshift. And everything else you archived in S3 bucket. So 2015, 2014, 2013 is in archive S3 bucket files. Now, with the Redshift Spectrum, if you run a report, it will take the data 2 years of 2017 and 2016 from Redshift, the MPP database, and then for 2015, 2014, 2013, it will go to S3. It will union both data and it will give you a report. So now you are getting the benefit of both EDW and EDL. That's really, really powerful. So that's why I'm calling this EDWL, and this gives you the best of both. So now you can keep only the most frequently used data in your Redshift, and the data prior, which is seldom used, you can archive it, and you can configure through your MicroStrategy, whatever your enterprise reporting tool, Tableau, whatever it is, you can access data from your Redshift as well as your data lake and the end user would not even know it. The only way they will know it is, oh, I ran a report before, it came in 30 seconds, but when I added 2014 and 2015, it took 2 minutes because it has to come from S3. They notice that slowness, but otherwise, from an experience point of view, other than the slowness, they will not even see that there is no difference. So and that is the power of Redshift Spectrum. I would definitely, if any of you are using Amazon Cloud, I would strongly encourage you guys to go and explore that. All right. So another product by having the data in the S3 is that you can use the Athena, which will give query as a service. So it's a serverless architecture. You can just access the data as a query as a service. I think there is a slight so I don't think with Athena you can directly access it as a query as a service, and then through Redshift you can access it the same thing for two different performance, two different access paths, and the performance slightly vary. I don't have the exact details how much performance they are variant, but all I know is you can access the data in both the ways.
What if we are not in Amazon?
Sorry?
What if we are not in Amazon?
I didn't understand the question.
What if you're not in Amazon?
Oh, this one is primarily Amazon Cloud architecture. So I'm talking here specifically in the data lake on the cloud architecture. So it could be whatever I said here, kind of sort of could be applied for all the three clouds: Google Cloud, Azure Cloud, and Amazon Cloud. But specific use cases I used here is Amazon Cloud. We predominantly focus on cloud architecture, all our data lakes. That's why we build lake on cloud. We predominantly build a data lake and architecture on the cloud. So if you're on-prem, I think it's a different architecture. I'm not an expert in that. We don't know.
I think the big consideration there is your data source, right? If your data source is on-prem, then have your data lake on-prem.
Yeah, if your data source is on-prem, I mean, you can move to cloud, but if you have not made that decision, if your organization has not made the decision to move to cloud, and if they are only in data center, then that's your only choice.
Right.
Then I think I know Jay here is architect. He may be able to give some. He has worked with Hortonworks. Maybe the on-prem solution may give. They may have some options in the on-prem.
Well, you can build data lake on Hadoop architecture. Like if you're on-prem and if you don't want to go to cloud, then Hadoop-based architecture is your alternative. It's pretty much is your choice.
Right. I'm just going against what will be your alternative if like Redshift because
Spectrum.
you're not on-prem.
I don't.
You're on-prem.
I think I can answer that question. Hortonworks has a product called HD Insight. Hortonworks. So it's Microsoft Azure and Hortonworks have done that. I don't know how well that product works, but they are trying to do the similar thing. So their architecture is they have a SQL Server PDW. It's an appliance, MPP appliance, and then underlining is a Hortonworks data lake, and then it has the intelligence catalog where if you run a query, you can have some of your data in your data lake on Hortonworks data lake, and some of it, the recent data could be on your SQL Server appliance, and it will route through that. I've come across, I've heard that architecture a few times. Personally, we have not worked with that. But, you know, I'm sure Cloudera will have a similar option. But Cloudera, again, it's all completely Hadoop. So when we are talking about both database and Hadoop, I know because of SQL Server and Hortonworks collaboration, I know they do that. But others, I don't know. There could be, I don't know.
AWS offering.
Yeah.
So what is your
Another option is you can move to cloud.
Well, the thing is, what's your data source again, right? So if you are, everything is.
No, I understand. Send me an email, I'll get back to you. You know, that one I don't know. I can check and get back to you on the on-prem technology. But also we are hiring. If you guys are, you know, if you are interested or if you know anyone interested, let us know. Our contact information. Thank you all very much. Yeah, sorry, go ahead.
What are the validation approach you are when you are ingesting the data in the data lake from the other sources? What are the validation approach you are right data is coming, the old data is coming, or maybe print message data when we are bringing the data in the lake?
I didn't understand the question.
You are bringing the data
Into the data lake.
What are the validation things?
The validation.
Yes.
Got it. Okay. I think the validation process is whatever is the validation process that you already do, right? It's the same thing. You can do the total row count, you can do the sum of stuff, whatever, right? The standard validation, data governance, data quality, those things apply.